Hello, today we're going to be talking about direct variation. A direct variation are when two quantities, x and y, are proportional So when they are proportional, the relationship can be represented by a direct variation. So proportional just means that they are increasing at the same rate. So to tell if a graph is a direct variation, the graph needs to be linear and must pass through the origin. Alright, so take just a second and see if you can figure out which graph would show a direct variation, graph A or graph B. Alright, so you should have picked graph B. So graph B is linear because it creates a straight line and it goes through the origin, the 0, 0 point. Alright, we can also tell from tables. To tell from a table, we look for a constant ratio of y over x. So we can take and set up each of our points as y over x and see if it's the same thing. So for graph A, we can set up our point 1, 3. So it's going to be 1/3. That won't reduce any. We can also use our point 2, 6. 2 over 6 we're reduced to 1/3. 3 over 9, that will also reduce to 1/3. 12 over 4, or 4 over 12, will reduce to 1/3. Let's check our graph B. So our first pair, we have 4 over 2, that is 2. Our second pair, we have 8 over 5, that won't reduce any, so graph A is our direct variation. I'm going to erase some of this. Alright, and from equations, we have that just plain equation, y equals mx. Since we are going through the origin, our b value would equal 0. That is why it's not included in this direct variation. So remember, y is our dependent variable, and x is our independent variable. M is our slope, so nothing is changing from our regular linear equations. We also call this the constant of variation and the unit rate. Sometimes we will see this written as k. For direct variation, they tend to use k for the slope. Not a big deal, but just make sure you remember that. Alright, so looking at these equations, it says circle the equations which show a direct variation. A is not a direct variation because of the 3. It will be going through the y-intercept at 3. B, we have 2y equals 4x. Let's go ahead and get that y by itself, so let's divide by 2. So y equals 2x. So is this in our form y equals mx? We have a number in front of our x. We don't have a y-intercept, so B is a direct variation. Let's look at equation C. We have y minus 1 is equal to 5x. I'm going to add 1 to both sides to get that y by itself. Remember, we can't combine 5x and 1 because they are not like terms. So we get y equals 5x plus 1. So here we do not have a direct variation because of that plus 1. And equation D, we have 1 half y equals 4x. So we want to get rid of the 1/2. Remember, to get rid of a fraction, we can multiply by the reciprocal. So I can multiply by 2 over 1, or just 2. What I do to one side, I have to do to the other. So 1/2 times 2 is 1, so I'm left with y equals 4x times 2 is 8x. So this has no y-intercept, so we go through the origin. So B and D are both direct variations. All right, and just one application problem before y'all get started. The cost y in dollars for x gigabytes of data on data plan is represented by y equals 10x. So use the table to graph the equation. So on the bottom, my x, my independent variable, is the number of gigabytes. So I'm going to put data down here. And gigabytes. And the y-axis is the cost in dollars. Alright, so use the table to graph the equation. So if x is 0, my equation is y equals 10 times 0, so my y value is 0. My ordered pair is going to be 0, 0. If x is 1, we end up with y equals 10 times 1. So our y value is 10. So our ordered pair is 1, 10. If x is 2, our equation is 10 times 2, which is 20. So our ordered pair is 2, 20. So I'm not going to write all of the numbers in. I'm going to count by 1/2 on the x-axis. So that second line is going to be 1, fourth line is going to be 2, and the sixth line is going to be 3. Up the y-axis, I'm going to count by 10s or 5s. So I'm going to skip every other one. So I have 0, then I have 5, 10, 15, 20, 25, 30. So we can just put in some of those dots: 0, 0, 1, 10, 2, 20, and draw our line through our points. Alright, so does y equal x represent a direct variation? Yes, it does. The easiest way, well, you can tell from any of them. I'm not going to write this down because there's a lot of writing and a little space for my iPad. You can tell by the equation because it follows our form, y equals mx. There is no y-intercept. We could tell from the table because we could set up our y over x. So 10 divided by 1 is 10. 20 divided by 2 is 10. On these direct variations, we ignore the 0, 0 because we can't divide by a 0. And you can also tell from the graph because it is a straight line and goes through the origin. Alright, part C says how much would 5 gigabytes of data cost? So this 5 gigabytes is our x value, so I'm going to plug it in for the x. Y equals 10 times 5. So that would cost $50. And last but not least, interpret the slope. So our slope in this problem is the number in front of the x, 10, which means the unit price is $10. So we're paying $10 from the y-axis for every gigabyte. Alright, so you are going to continue on with this form, and you are going to see if you can understand what direct variation is. If you have any questions, please ask.